All right, Algebra 2, today we are going to simplify cube roots, fourth roots, fifth roots. But first we're going to look at the square root of 40, and we're going to recall how to simplify that. So the square root of 40, if you remember, we used our list of perfect squares, and we found on the list of perfect squares, we found 4, which is a factor of 40. So we split this into the square root of 4 and the square root of 10. And now what's the square root of 4? Well, that's 2, so this is 2 root 10. And that's how we simplified square roots. Now we're going to simplify cube roots. So if you look at your list of perfect cubes, you have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, etc. So now we're looking at that list, and we want to find which of these numbers go into 40, and of course that would be 8. So we're splitting it into the cube root of 8, and 8 times 5 is 40, so cube root of 5. So here on this first one we did the square root of 4 because 4 is a perfect square. Here we need to find a perfect cube that goes into 40, which is 8. And since the cube root of 8 is 2, we have 2 cube root 5. So there's how we simplify cube roots. So look at example number 1. We have the cube root of 125. Well, hopefully you know or look at your sheet to tell you that this is just 5 and done. Well, what about the cube root of, or the fourth root of 2? So if we look at our perfect fourth powers, we have 1 to the fourth, which is 1, 2 to the fourth, which is 16, 3 to the fourth, which is 81, 4 to the fourth, which is 256. So in number 2, we need to find a perfect fourth power that goes into 32. So we are going to take 16. And so we're going to split this into the fourth root of 16, and the fourth root of 16 times 2 is 32. Now, what is the fourth root of 16? Well, the fourth root of 16 is 2, so this is 2, fourth root, 2. Okay, what about the cube root of 54? Number 3, the cube root of 54. So we want perfect cube, so we're looking at this set of numbers here. And we need to figure out, okay, what goes into 54? Is it 1? Well, 1 goes into everything, so we don't worry about our 1s. Is it 8? Is it 27? Is it 64? Well, it happens to be 27. Okay, so how many times does 27 go into 54? And it goes in twice. So we're going to split this into the cube root of 27 times the cube root of 2, because 27 times 2 is 54. Why did we pick 27? Because that's one of our perfect cubes. What is the cube root of 27? Well, that would be 3. So this is 3 cube root 2. Okay, now let's move on to variables. Now we have the cube root of x cubed. Okay, so let's think for a minute. Okay, the x's always seem to confuse us, but let's think of terms of number 1. This is technically the cube root of 5 cubed. Okay, because 125 is 5 to the third power. So the cube root of 5 cubed is simply 5. Okay, if you cube it and then cube root it, you've brought it back to its original number. Same thing with variables. So this is x to the third, cube root it. We are putting it to the third power, and then we're undoing that. So this is just x. Okay, so looking at number 5, that is not going to work as easily. But what can you take a fifth root of? Well, you can take a fifth root of x to the fifth. So let's split this up. We have an x to the fifth. We could have another x to the fifth. And left over we would have an x squared. X to the fifth, and x squared is x to the 12th. Why do we want to split it into x to the fifths? Because we can fifth root those. And if we want to split this up further so we can see this, we're going to have the fifth root of x to the fifth times the fifth root of x to the fifth times the fifth root of x to the second. Just like on number 4 here, the cube root of x cubed is x. the fifth root of x to the fifth is x, times the fifth root of x to the fifth, that's another x, times the fifth root of x squared, oops, is just going to stay the fifth root of x squared. So how do we write this correctly? We're going to have x squared, x times x is x squared, times the fifth root of x squared. All right, so let's think about that again on number 6. We're going to do these a couple times, and the more often you do them, the more they start to make sense. So on number 6, we have cube root of 125. Well, hopefully we know that that's 5. Okay, so that's going to be 5. And then we've got more to deal with here. We've got the cube root of x to the 6th. If you remember, we want to think of it in terms of x to the thirds. So this is going to be the cube root of x to the third. That's 3 of them. We need 6 total, so another x to the third. So we have 5 cube root x to the third, cube root x to the third, which is 5 times x, which is 5x squared. Okay, so that worked out nice and pretty. Now, do you need all of that work shown? No, not at all. Let's actually go back through and talk about those without writing it all out. Okay, number 5, we still need to think about this in terms of x to the fifths. But essentially what we need is x to the fifth, x to the fifth, x squared. There are 2 x to the fifths in there. And we're going to leave these 2 on the inside. Done. Think about number 6. So this is going to be 5. And x to the 6 can be written as x cubed, and the cube root of x cubed is x, and the cube root of x cubed is x, so there are 2 of them that we can take out. Another thing people do is divide. 12 divided by 5, there's 2 you can take out, and 2 left over on the inside. 6 divided by 3, there's 2 you can take out, and none left on the inside. All right, let's apply those same concepts here to number 7. Okay, how many x to the thirds are here? We have x to the third, x to the third. So there are 2 that you can take out. So this is going to be an x squared and nothing left inside. How about y to the 8th? How many y to the thirds are there? Well, y to the third, that's 6 of them. Y to the second. So we're going to take out this one. We're going to take out this one. So we're taking out 2. And we're leaving in 2. Or again, 8 divided by 3 is 2. So there's 2 out here with 2 left over. How about z to the 13th? So we're going to have z to the third, z to the third, z to the third, that's 9, z to the third, that's 12. One more z, there's 13. So we're taking out 1, 2, 3, 4. So we've got z to the 4th out here. And it's left with 1 on the inside. So again, if you use the division, we've got 13 divided by 3 is 4, so there's 4 on the outside, and that leaves you with 1 on the inside. All right, last one, number 8. Now we're going to combine variables with numbers. So we have the cube root of 16. So first thing we need to do is we need to simplify the cube root of 16. So what I like to do here is draw my answer off to the side. This is going to be a cube root, and I'm going to leave some things inside, and I'm going to pull some things outside. So 16 is going to split up into the cube root of 8 and 2. Okay, 8 times 2 is 16. Why did I pick 8? Because 8 is one of my perfect cubes. So what is the cube root of 8? Well, the cube root of 8 is 2. What's left on the inside? Another 2. How about a to the 7th? We need as many a cubes as we can. So we've got a to the third, that's 6. There's another one that's 7. What's the cube root of a to the third? We're going to do that twice. So that's a squared. Those are those 2, and that leaves you with an a inside. And b to the 6th, we can write b to the 6th as b to the third, b to the third, No leftover, so we're pulling out b squared, and there's no b's left on the inside. So there is your answer for 8. These take lots and lots and lots and lots of practice. So if you're not getting it at first, keep working, get people to help you, ask your teacher. You can definitely do these. They just take a little bit of time. So now what I want you to do is go ahead and work through these video examples, and we will go through them and talk about them in class tomorrow. Have a great day.